Hi, I'm out here in Norfolk, Virginia, and I'm here to visit a couple of friends that I met at the Wooden Boat School last summer, Tom and Joe. Tom runs the Tidewater Wooden Boat Workshop, which is an amazing project that he's created. So I'm going to volunteer with them for about 3 days and tell you a little bit about what they do there. But in the meantime, I want to go back to the studio and do a little recap on the lead keel casting. My name is Bob Emser. I'm a sculptor and a boat builder. My sculptures have always been inspired by nautical and aeronautical imagery. In fact, sometimes people passing by my studio would ask if I'm building a boat. I've always enjoyed the artistry of wooden boats. It seems like I've been building boats for over 40 years, and now I'm building sculptures that float. Welcome to the art of boat building. Well, welcome back. Today I thought we would go through some takeaways that I got from casting the lead keel and to address maybe a couple of concerns that I wasn't clear about before. The first thing that I did was I took a cold chisel and I chiseled away the flashing that was on the top of the centerboard trunk mold to clear it so that I had all of the wood exposed. Then I flipped it over and used a crowbar to chisel off the excess wood that was sticking up out of the bottom of the casting. And then flipping the mold over, I started working on drilling a series of holes through the centerboard slot with a 1 1/8 inch bit. This would help relieve some of the pressure so I'd be able to chisel the wood out of there easily. What made this work really fast was I have these bits made by Bad Dog, and they're called rover bits. And you can see they're really, they've got 4 carbide blades on there, and what they're designed to do is to weave inside. You can actually turn a corner with these bits. They really made short work of drilling through that centerboard. The rover bits, I bought these at the Wooden Boat Show in Mystic, Connecticut last summer, and I'll put the link in the description below. They're a little pricey, but they certainly do the job, and they're the right tool for this application. You can see once I got all of those holes drilled and worked on it with the chisel a little bit, that centerboard slot mold popped out very easily. After I got the centerboard slot cleared, I then rolled the mold over and got to work on the flashing. I used my pneumatic hammer drill with a flat chisel on the end of it to make short work of cutting that flashing off there. I certainly could have used a hand chisel and a hammer, would have taken a lot longer, and there was something kind of satisfying about watching this flashing curl off of the casting. Once that was done, I cleaned it up a little bit with a file, and it's good to go for now. One question that had arose was about the pipes, the vent pipes that were over the top of the mold where it was completely encased. It's really important that when a mold is completely encased, there's a place for the gases to escape. Now these vent pipes actually did 2 purposes. One of the reasons why the plan calls for it being an 1.5 inch piece of pipe, which seemed a little bit overkill for the amount of space that is there. But in addition to being vent pipes, they actually acted as fill pipes also. And what I mean by fill pipes is you can see that when the metal started to contract as it cooled, in that area, it would have pulled it off of the top of the mold. So in order to alleviate that, these plugs that came out of there were actually acted as fills. And you can see how it actually indented in there, and as it cooled, it sucked metal away from that fill. So you can say even in this one, did the same thing. So that's why they're that size, and that I've heard of people using smaller ones which will not work quite as well, and they have a better chance of getting a porosity in the top of their mold, in the top of their casting, if they were to do that. So, vent pipes, two purposes: venting gases and filling hot metal as it cooled. One of the other questions I had was what type of valve was used for the lead to come out. And there really was not a valve per se at all. What it was just the elbow as it came out of the melter, and that I would have it raised up while the melting was going on, and then once we were ready to have it pour, then I was able just to lower that back down just by letting the elbow turn. So the valve was basically the elbow turning up and down, just like in this piece of pipe that I have here. One of the other questions that I've been asked is what the final casting weighs. I don't really have a scale handy, short of loading it on my truck and taking it to the grain elevator and having them weigh it for me. I wouldn't have any way of knowing that. But what I can do is figure out how much lead I started with and how much scrap that I've ended up with, and then subtracting that. So I started with 610 pounds in the melter, and then accounting for the spill that had happened, which weighs about 25 pounds, give or take, and also the flashing that I cut off, which was about 5 pounds, and then the little bits of plugs that came out of those filler tubes. So I ended up with about 575 pounds to 580 pounds. Now the plans call for 585 pounds. Now the good thing about being a little less is you can add lead, especially in amongst the bed logs. Now, for example, this ingot right here, which you can see isn't extremely large in volume, it weighs 10 pounds. So one of the benefits to being able to set ballast that way is then you can also determine whether it needs to be a little bit more fore in the boat or a little bit aft in the boat. Because ideally what you want is for your boat, when it's sitting, that the marked water line on the boat matches the actual water line of the water. So if your boat is a little bit canted one way or the other, then you'd be able to move some of those smaller ballasts back and forth in the boat. So in some ways, it's better to have a little less than a little bit too much. Now I know I'm going to lose a little more when I drill holes in it, and there's some trimming that happens at the stern and so forth. So, but in boat building, close enough is good enough. When I was out at the boat building school, the saying was, we're not building furniture, we're building boats. One concern that some of you seem to have was the strength of the melter's legs. I can assure you that they were very strong. They were welded out of 3/16" heavy angle iron, and they were double welded with stainless steel filler rod. In addition, the legs were set out on a canter, and they had a brace going across the bottom. It was very strong. Even with the full load of lead in there, there was absolutely no wiggle in it. In fact, probably the more weight that was in there, the stronger it seemed to get. So if I were to do it over again, that is one thing that I would not change. The one thing that I would change is I would, instead of having just held that splash guard by the mold, I would have actually attached it to the mold, perhaps one on each side. But we were prepared for something like that happening. Had 8 inches of sand bed spread over the whole work surface and had a shovel handy. So we were prepared for the event of something like that happening. All in all, I'm really pleased with the way the casting went. The casting itself has absolutely no porosity in it. It's a good solid casting, and the dimensions are pretty true to what the plans say. So all in all, pretty happy with the way it came out. So let's head back out to Norfolk, Virginia at the Tidewater Wooden Boat Workshop. I met up with my friend Tom Brattle, who is the founder and executive director of the workshop, and I asked him to tell me a little bit about it.
Tidewater Wooden Boat Workshop is a nonprofit here in Norfolk, Virginia that teaches math, science, and life skills to disadvantaged youth ages 12 through 18. We do that through the building of wooden boats, and then also we take the kids out on the water and we teach them how to row and sail the boats that they built.
So how many years have you been doing it?
We've been doing this now for a little over 4.5 years, and we've had close to 700 young men and women come through our programs, either our after-school program, our during school time program, because we team with other with schools and with homeschool groups, and then we also do 1-week summer camps where we bring a lot of kids through for the exposure to what we do here at the shop.
So you're the founder.
I am the founder.
And so give me just a little brief idea about how you got started.
I was in the Marine Corps for 29 years, and when I retired, my colleagues that I work with in the Marine Corps, they gave me a gift certificate to attend the Wooden Boat School up in Maine, and I didn't use the thing for a few years, finally went, and that was a life-changing experience. Took a 2-week course, Fundamentals of Boat Building, started building a boat in my garage. I came back the following summer, took another course, and I started hearing about these youth boat building programs across the country. And I thought, well, heck, there's got to be one back in my hometown, Norfolk. And I thought I could volunteer at one, and found out that there wasn't one. So I started Tidewater Wooden Boat Workshop because we had no youth boat building programs. At the time, I think there were over 60 youth boat building programs across the country, but we didn't have one here in Norfolk, of all places. We're surrounded by water, you know, the largest Navy base in the world, a big maritime history, and there was no youth boat building program. So I decided to start one. My colleague in this is Joe Filipowski. He's been building boats here in the area for probably about 50 years or more. And he did a number of projects with kids over the years. And somebody introduced us, and he and I, from the very first day we met at my kitchen table, we decided we wanted to do a program like this, and we were planning it from day one. He was helping me with the boat I was building in my garage. And but when we broke for lunch that day, we started planning this. And that was way back in 2013 actually. The future? Well, we're continuing to grow. Each year we're seeing more kids come through our programs. We want to expand, do a little bit more on-water activities. Now that we're starting to produce the sailboats here with the kids, we want to get more sailing. We're getting volunteers that are very experienced sailors. So this past summer was our first time that we had the kids out on the water, not just rowing, but also sailing. And the excitement of seeing a young man or lady that has never held a tiller in their hand, you know, the excitement in their eyes of taking that boat out on the water and feeling the power of the wind, you know, propelling them through the water was just amazing.
After spending 3 days at the workshop, I had an extra day, so I headed up to Newport News, Virginia, to the Maritime Museum and Park. If you're a Civil War buff, this is a must-see museum, as they have the turret from the USS Monitor here that they're making some conservation efforts to archaeologically document. In addition, they have a really great collection of model ships here. Being an old model maker myself, I really was able to enjoy the detail and artistry of these models. My main purpose for visiting was the International Small Craft Center. Its collection has over 150 boats. The collection is oriented to a wide audience, with boats from 42 countries and from diverse cultures. Several boats caught my attention, two of which were Nathaniel Herreshoff designs. Dilemma is a 38-foot sloop, 25 foot at the waterline. All of the racing yachts of Dilemma's day had heavy keels that ran the full length of the boat. Herreshoff gave Dilemma a fin keel centered on the weight of the bulb on the base. He also moved the rudder back from the trailing edge of the keel to make the boat more responsive to steering. Dilemmas inspired the design not only of the 1967 America Cup Defender Intrepid, but all the current America Cup yachts as well. I was excited to see a Herreshoff 12.5 in their collection. Though I've sailed a Herreshoff 12.5 many times, I have not seen one out of the water. It was exciting for me to see her details. As many of you know, the haven that I'm building is based on the Herreshoff 12.5. The other boat that caught my attention was a 1935 19-foot Chris Craft runabout. This early series of custom runabouts is the predecessor of the later barrelback customs. The barrelback we all are familiar with were based on the same hull. Perhaps my next boat will be a barrelback runabout. Well, that's my visit to the Maritime Museum Center. I hope you enjoyed this episode. We'll get back to Illinois and get started working on the haven again. The next thing up is planking, so I'm excited about that. So we'll see you next time on The Art of Boat Building.